Okay, hello everyone. In this video, we'll do a very important question. Is merge sort. We're gonna sort our linked list, okay, using merge sort. So in case if you have no idea about merge sort, what we do in merge sort is we actually are given a linked list. We are given either an array or linked list. So in this case, we'll be actually dealing with a linked list, okay. So in case I have been given a linked list like 1, 5, 9, 3, 2, 7, 8. Example. Let's just take a simple example that this is our linked list that we are given and we need to sort it. Okay, we need to sort this linked list. So what we do in your this merge sort is, what we will do, we'll actually try to divide two two different linked lists. That means we'll try to divide our linked list into two parts, okay, from the mid. Now you know why we have created the mid function, because see, even the in the previous videos we have created the mid function, we have created the merge function. Where did we do our merge function? We did our merge function on two sorted linked lists, right? Here also we're gonna get the similar case. I'll explain you how we'll be getting it. Okay, so see, we'll try to actually divide our linked list into two subparts. That means this linked list will be divided in two parts. Okay, first this part. That means what is the mid? The mid is 3, right? The mid is 3. So we'll try to actually divide it like this: 5, 9, 3 till here, and from the other part will be this, and we'll try to actually merge them. Okay, so we have divided this two part, but we still can't merge. Why we can't merge? Because they are not sorted, and we have learned that we can merge when those two linked lists will be sorted. So again we'll actually try to divide this linked list. So when we divide this, it will be divided like this, and this will be divided like this, right? So this will get divided into two parts: 1, 5, 9 and 3. Here it will be divided into two parts again: 2, 7 and 8. Okay, so again, not sorted. It is not sorted. Okay, there are still two elements. We have no idea whether they are sorted or not. So we'll divide it again and we'll try to sort it. Divide it. So 1 and 5. This will get divided into 2 again. 9 and 3. Okay, this will divide into 2 and 7. Now this is 1. See, if there is one element inside a linked list, it is sorted, right? Obviously, there is one linked list, one node, one data. Nothing is to be sorted. This is already sorted. So just return. Okay, if you found that there is only one data inside our linked list, now we'll return. Okay, so at this case, okay, we can see that there are one. So obviously when this will return, saying that hey there, I am sorted. Okay, and even this will say that I am sorted. It will go at this point. Okay, that means here we are going to use recursion. Recursion will try to break this problem into sub problems. Okay, so at this point we came at here and we say that we have two different linked lists. Okay, we have two different linked lists, and now they're saying that they are sorted. So we'll call the merge function on this. Okay, merge function on this 2 and 7, and it will get merged into this. Obviously they were sorted, but we have no idea whether they're sorted or not, right? Example, in this case, 9 and 3. 9 and 3 will say that they are sorted. They are sorted, and at this point we'll try to sort them. So if their two are sorted, we'll call the merge function at this point. Okay, when I'm this green line, and that merge function will sort this part of the linked list. Understanding it? Even 1 and 5 will say that they are sorted. So when we will be at this 1 and 5, we have already divided these two into two different linked lists, and now we are returning back because they two are saying that hey there, we are only one element and we are sorted. So at this point we'll actually again sort them, and it will get sorted like this: 1, 5, 3, 9, 2, 7 and 8. Simple. Now this and this, now this will call on this part 3 and 9 and 1 and 5, saying that now this 1 and 5 will say that hey, I have actually gone through all the functions. Okay, and now I am sorted. Okay, 1 and 5 I'm sorted, 3 and 9 I'm sorted. Now at this point this okay, at this point we'll try to merge this part of the linked list. That means now we have two parts, that is 1 and 5 and 3 and 9. Okay, 3 and 9, 1 and 5, and now we have two different linked lists and we will sort them using which function? Merge function. That means we will be calling merge function at one point of time. So merge function will merge these two and eventually we will get this at this stage. That means now we have got a sorted linked list, and from here also 2 and 7 will say that I am sorted, 8 is saying I am sorted, and when these two will be, again merge function will be called here, and now this is sorted. Now can you see 1593 was not sorted, but as soon as we went and we break it into sub problems and we were returning back, we see that it gets sorted, it gets sorted. So finally, as we have divided our main problem into two sub problems, saying that if you guys are sorted, then I'll call merge function on you guys. So as soon as now we can see it went into slow steps, and now they are merged, they are sorted. So as soon as it's returning, we are gonna actually merge them. Now we will be calling merged on if this is half 2, okay, of the main linked list, and this is half 1. Then we need to merge, call merge on half 1 and half 2. What this merge function will do, it will merge both the linked list and give us the answer as 1, 2, 3 or 5, 7, 8, 9, the required answer. So now you got the main motive of creating the mid function and merge function before this video, right? Now you have the clear idea why we created the mid function merge function, so that we can use inside our merge sort. Okay, so okay, I hope I cannot actually say that you would have actually understood 100%, but if there are some doubts while we'll be coding it, we'll actually understand, and even those doubts will get clear. Okay, so let's just start the coding part and we'll just eventually understand what's actually happening inside. So let me just start the coding part. So merge sort, we will be calling on we merge sort. Okay, it's gonna have only one linked list, right? It is gonna return something after getting sorted. It will return something. Now, as I told you, we need to actually come inside. First of all, check one thing: is your linked list empty? That means if it is null, that means no elements are there inside the linked list. That means just return head. Okay, and if your heads next is null, that means there's only one element, and one element means it's sorted. Okay, so what we need to do, just return head. Simple. Because first of all, see, this is for the beginning case, if in case there are no elements. Okay, but this part is if in case there's only one element. Since we will be breaking our linked list into sub problems, this is actually the base case, I should say, base case. Okay, this part had snacks equal now. In regression, you know, right, we need base case. So why we require recursion? Because we'll do the same thing again and again. Okay, that's why we will be requiring the recursion. So see, after we have, okay, this was our base case, that's just simple. What we need to do, that's the main part, right? First we need to actually break it into mid. We need to have our mid. So let's just call our mid function onto our head. What will it return? It will return a node that says that is the mid, right? Example, if I call my mid on this main function, okay, it's getting congested. Let me write it here at the bottom. Okay, I'll just use this part. Okay, let's use this part. Let me write here 15932. So what is the mid? The mid is 3. So from 3 onwards, I'll take in one part, okay, one part, and after 3, whatever is there, to till end, it will be one part, half 2, half 1, okay. So we need to have two nodes, okay. Obviously, we'll do the dry run at the end so that you understand it properly, okay. But before that, let's just understand the coding part as well. So now I have called the mid, and now I'm gonna even have our half 1. What is half 1? Your half 1 is the part of the from head till your mid. So obviously, uh, see, you have this is your half 1 part. So from this was actually the head, original head, right? This is your original head. So from half to this is now the mid, to till mid, right? Till mid. So if till mid, that means mid next. Now see, mid's next is pointing to 2, but mid. So if in case I make mid's next as null, this part will get disappeared, right? And this is my motive to make the first half. So let's do this. So obviously your uh, mid's next should be null, so that your half 1 part is ready, right? Half 1 part is ready, and we will call merge sort on that as well. It means we need to even merge that function, like we need to even I'll just tell you, we need to even, I have done half. Now in that half also I will be doing the half, okay. So I'll explain you what I'm doing. So let's just call half 1. Now there's a problem, there's a small problem, okay. I need even half 2, right? Even I need half 2. What is the half 2 part? This half 2 part is actually from mid's next, right? From mid's next to null. So if in case I write like this and just initialize mid's next as null, that means that part of the linked list is vanished because the address is not stored there. So before actually making the mid snacks as null, I'll have to store its value inside this half 2, okay. So I hope you're understanding this line. What we did with this from this line is, I'll erase this part and then we'll even do the try run once again. So let me just do again. Let me select everything. So let's place this part. Let's take an example, small example. 1, 3, 2, 7, 5. Any example. 9, 8. Okay. Example. So now this is the mid. This will be the mid, right? So what I did before making mid as null, I actually tried and made from mid's next inside half 2, and later this is gonna be your half 1. Okay. Now see, if you see properly, even this is not sorted, right? Even now this part is not sorted. So again I have to call the same merge function on this part as well. Okay, you understanding it? How the calling and dividing this part into 2 as well. So we did the same thing. See, recursion is gonna handle everything. So see, half 1 had, you know why we did had, because we're gonna take from the beginning, this from mid's next. Why we made it null? Because we want the half 1 to end at mid exactly, okay. That's why mid next is null, so it's gonna end at mid, okay. After we did these things, we'll call the merge sort on both the halves. It means here you guys, you just go and sort your element and find the answer, okay. So I'll explain you what I'm doing. Let me just complete the code and I'll explain you what we are doing, and we will actually add, and at the end we can assume that we are getting the answers. That means recursion brings the correct answer. Okay, from both the part. Recursion brings the correct. We can assume that both the parts we will be getting our correct answers. We will be getting sorted. That means our sort function would have worked out there. So what we were about to do with the last part, we were about to merge, right? Merge both the halves, half 1 and half 2, isn't it? We're about to merge both of the part, and this merge function actually returns something, a node pointer. So let's make it final, or just like it, make it your final answer. Okay, right, and eventually we will return final answer. I know it's a bit, it will take some time to understand, but let's just do the dry run and obviously you'll understand. Okay, whatever we're doing here, we'll do the dry run. Let's do the dry run. So what we did, first of all, we'll break it into two parts. We'll break into two parts. We'll split into half 1, half 2, and again call the recursion on both the halves. Eventually, once we get both of them as sorted, we will actually combine them inside the merge function and finally return it. This is the approach that we will be using. Let's do the dry run on this answer. Okay, so let's take here 1 3 2 7 5 9 8. No, this is our answer that we have got, our question that we have got. We need to sort it. So what we will be doing is, first we will be taking a mid. What is the mid? 7 is the mid. So I calculated 7 and it got divided into two parts. That is, first half is going to contain 2 7, and what we did here 5 9 8 and null, and from line numbers 129 mids next became null, right? So now you know why we did null. So mid was 7, so it's null, next became null, so this is null. Simple. Both of them are not sorted yet. See, even these two are not sorted. So what we did was, again we came back and we called the sort function both the halves. So again, now this will get divided because now the mid is 3, so it will be divided into this 1 3 2 7. Okay, or for that sake, so that we don't actually get confused, let's, like, in order to understand, let's make 7 here and 2 here. Okay, so that we see how actually it's working. Okay, 7 here and 2 here, so it gets break into this. Now I have no idea whether they are sorted or not. They are not sorted, I know. So again, I'll call the same merge function because their element, it still has more than one element, right? So I called again the half, same thing, and it got divided into 1 and 3, and this got divided into 7 and 2. And in this part, what is the mid value? 9 is the mid value, right? So it will get break into this, isn't it? Simple. Till now we understood what we are doing, because at every point we are just dividing it. Okay, till now we have just divided. Okay, so now when this at 1, now this is a single element. Okay, now this is a single element. So this, when this, let me change the color. Okay, now when this was divided into 2 1 and 3, they now became single elements. So now this is returning, this is gonna return and say that I am sorted, and when this is gonna return and say that, hey, I am sorted. So what's the use, what do we do actually when we have two sorted arrays? We actually merge them, and when we merge them we get this value. Okay, now even 7 will say that I'm sorted, 2 will say I'm sorted, and at this point where the call was been made, it will actually merge the two sorted arrays. Then it will actually become this. You're understanding it? At one point it came, see, in half 1 and half 2 the values are stored, 7 is stored and 2 is stored. Okay, so when we came here, we actually merged them and we returned the value. Okay, we merged them and then we returned the value. I hope it's making sense. Okay, same goes with here. It is saying that hey, I'm sorted, return me. So it's gonna go and store into half two. Okay, and even this is saying that okay, this is not saying still. This is gonna again still break into two things 5 9. Now it's single element, single element. Now it's saying that hey, I'm sorted, I'm sorted. So now this part is gonna merge them. So if it merges them, it's gonna be 5 9, and now there's gonna be 8. Now they are returning back. Okay, now they are returning back. So now 5 9 is there, 8 is there. These two are sorted as, and at this point, what will happen is merge will be called on both the halves, and eventually it will get merged into this. Right. Since we know how function works because we have done that in the previous video, right? Just previous to this. So I hope you know why and how it came to this conclusion, right? Okay, same goes with here. 1 and 3 sorted, 2 and 7 is sorted. So when at this point we will merge them, eventually we will get 1, 2, 3, 7. Okay, you understanding it? Now what happens is, now we are at the end part. End part means, as I told you, since we were assuming in the beginning, we were assuming, see, half one is going to give us the correct answer. Recursion brings the correct answer. I have written it. It means this is guaranteed going to return us the sorted array, sorted linked list. Even this half two is guaranteed going to return us the sorted linked list, provided our base case is written correctly. Okay, provided our base case is written correctly. So see, we have written our base case correctly. That means if there is one element, then obviously it is sorted. So we have written our base properly. We are assuming that these two are gonna return answers correctly, and see, we even saw that they are returning correct answers, right? Half one is, this was our half one, right? This is our half one, and it's returning a sorted array as we expected, sorted linked list. Sorry, this is our half two. Even this is returning a sorted linked list. We can see it. That means our assumption was correct, right? Now after the assumptions, what we did was we actually stored their value by merging them. Okay, half one and half two were merged, and after merging them we will be getting our final answer and we will return the final answer. So as soon as we merge them, I'll just write the answer here. Okay, final answer I will write here. We will be getting our answers as 1, 2, 3. We, assuming that you guys know how merge function works, 5, 7, 8, 9, and this will be our merge sorts answer. I hope you understood the tracing of this linked list. Okay, at every point we are breaking our linked list into two halves, and we'll keep on breaking until and unless we are sure that it is sorted. Okay, so as soon as we get one element, we are sure that it is sorted. So we are like, okay, you are sorted now. Now return back, and now it's time for merging. Okay, this is the thing that we actually do, right? Because see, 1 and 3 were sorted, so we returned at here at this point and we were merging both of them, right? So this is the approach, and now let's just check our function is working fine or not. Let's just check it. Let's just run it. So I'll call merge sort on okay, this was actually our merge. See, merge function, we know how it gets merged, right? So right now I'll just not merge it. I'll try to first call our merge sort on hand, okay, which is actually going to be stored inside merged. Okay, that is right, merged. Okay, merg, merged, right? And let me just print the merged value. Hopefully we will be giving an unsorted array, and that array should be sorted if everything is written correctly. Okay, so I hope, let's see. Okay, first error that we got is this. What is the error that it's saying? Okay, I did not give a pointer, so obviously it's saying that that's gonna return an address, so we need to start, right? And what is here, because null should be capital letters. What's the error out here? Head, acha, acha, it's head one, because right, so let's just make it head. Let's just make it head. Merged small cities. That's okay, fine. I guess this should work now. Fine. Let's just check. So we'll give the same error that I have, same value that I've used here. What did I use? 13725. Okay, 13725. What else was there? 98. 98 minus 1. If everything goes, if everything goes right, we should get a sorted array. And here is it. We got our array as sorted. I hope you know how we got this, because we did the same tracing of the same this question out here, right? Okay, so in case if you didn't understand, just go through the video once again, and I hope you will surely understand. In case, and even if you don't understand, just ask me, and obviously I'll help you in that, if in case you need my help, or else I guess you would be able to do this question. Okay, we'll do some new questions in the next videos. Okay, thank you.